This video we're going to show the basic understanding and operation of the low-level MIP system, which is actually just the addition of the pulse flow controller into the standard MIP equipment. The addition of the low-level technology will improve the specific MIP detector system's response by at least 10 times over its response in standard MIP mode. Operators must have current FI-based instrumentation to run this method, and it takes approximately 30% longer to perform a log because of the need to wait for not only the sample to collect but also to travel up the trunk line before continuing to the next sampling interval. Besides the additional time, there's not much difference in the MIP operation. The timing process is fully automated in the software and does not include any sample trapping. Next, we'll review the MIP theory of operation. There is a semi-permeable membrane housed on a steel block which is heated to 120 degrees Celsius. This heat encourages contaminant volatilization and diffusion across the membrane, which is primarily driven by the concentration gradient outside the probe to behind the membrane. Internally, there is a continuous carrier gas that sweeps past the backside of the membrane, collecting and delivering volatile contaminants to the gas phase detectors at the surface. When we add the pulse flow controller to the MIP system, it allows the carrier gas to be plugged off when we reach a sampling interval. Blocking the carrier gas flow allows the contaminants to build up into what we describe as a slug behind the membrane. Once the sample collection time is over, the carrier gas flow is released and the contaminant slug is quickly swept to the surface. While the trunk line flow has been blocked off during sample collection, a second carrier gas from the nitrogen tank is delivered to the detectors to avoid wildly drifting baselines. To modify a current MIP system into a low-level system just requires an MP9000 pulse flow controller added to the MIP instrumentation. All of the gas lines get plumbed into the back of the pulse flow controller, which is managing the start and stop and direction of carrier gas flows. We start with the regulated output from the MIP controller, which is used to supply the trunk line carrier. Both the trunk line supply and return lines are then connected to the instrument. Then we have a secondary nitrogen tank supply, which is mostly used to feed the carrier gas line to the detectors. This is needed to maintain stability of the detector baselines during sample collection when the trunk line flow has been stopped. Here's some schematics of how this is actually occurring. This is the standard standby mode, and this is basically what's happening most of the time. We have a continuous carrier gas going through the probe back up to the controller and goes to vent, and a second carrier gas, which is clean gas from a nitrogen tank, which goes through and comes to the detectors. That way, when we stop the flow to collect our samples, the detectors will not respond erratically as they typically would if you change flow drastically. So flow is being consistently run to the detectors. The carrier gas to the probe is stopped. We build up that slug of contaminants. When that time interval is over for the sampling interval, we'll release the gas. The contaminant slug is brought to the surface, and when it's near the controller, and this is a timing issue that the operator has to figure out before beginning, that valve will be switched, directing that contaminant over to the detectors, and then it'll go back to the standby mode. The difference in the response magnitude between the two methods, standard MIP and low-level MIP, is described here. And in standard MIP, as we have that continuous flow bringing the contaminants to the surface, we're seeing for 500 parts per billion TC about a 4,000 to 5,000 microvolt response, where in low-level mode, that slug of contaminants reads about 60 to 70,000 microvolts. Here's an example of low-level MI HPT log. Looking specifically at the detectors, you're going to see that it definitely looks different. We are truly getting just samples right where we're stopping and collecting that slug of contaminants, and it will respond in a sharp spike. But you can essentially read it the same way as a standard MIP log, going from lower to higher responses and where the contaminants are present. One last thing to keep in mind when preparing site project reports, if you've done both low-level and standard MIP on a site, just remember that these are two very different data sets and they need to be handled that way in the report.